Hello there.
And welcome to AP Physics 1 in a Nutshell, Episode 2, Forces. Since this is one of the largest and most important units of AP Physics, this unit will be split into two videos. Part 1 will be an introduction to Newton's laws and some of the basic forces you will often see throughout your time in physics. Part 2 will be on the applications of those forces and some of the more difficult forces you will come across. Now on to Part 1. So what is a force? By definition, a force is an interaction with an object that will affect the movement of that object when unopposed. The magnitude of a force can be measured in either pounds or newtons, but we will only be using newtons here. Speaking of Newton, let's get to one of the most important parts of this unit, Newton's 3 laws of physics. Newton's first law is the law of inertia. Inertia is an object's resistance to a force changing its state of motion. An object's inertia most often comes from its mass, which we measure in kilograms. We will not be talking about the cases where inertia is not from the mass until we talk about rotation. Newton's first law states that every object will remain in its present state of motion until it is acted on by an external net force. Newton's second law is the law you will be actively using the most. Newton's second law states that the net force on an object, which is the sum of all of the forces on that object, is equal to the object's mass times its acceleration. This is another way of saying that a newton is equivalent to a kilogram meter per second squared. Newton's third law is the rule of 2. Not the Star Wars Sith rule of 2. It is the law that states that there is an equal and opposite force that is created as a reaction to any force. However, it is important to note that these opposite forces act on different objects. Let's talk about some of the more common forces you will see. The most common forces you will see throughout your time in AP Physics are weight, normal force, kinetic friction, static friction, gravitational force, tension, centripetal force, torque, spring force, electric force, magnetic force, and a few others. For now, we are only going to talk about weight, normal force, kinetic friction, static friction, tension, gravitational force, and centripetal force.
Now that's a lot of
forces.
Let's go through these one by one. Weight is the force of gravity pulling an object to the ground. When standing on the surface of a planet, such as the Earth, this force will always be directed downwards. Weight is equal to mass times the acceleration of gravity, which is 9.8 meters per second squared on Earth. Let's go on a quick tangent and talk about the difference between weight and mass, which can be difficult for those not trained in the art of physics to understand. Mass is how much stuff something is made out of and is measured in kilograms in the metric system or slugs in the customary system. Yes, slugs are a unit of measuring mass. Look it up. Weight is the force of gravity pulling a mass to the ground. Weight is measured in newtons in the metric system or pounds in the customary system. A good way to differentiate them is to think about going to the moon. Let's say you weigh 180 pounds or 800 newtons on Earth. That would mean your mass is about 81.7 kilograms or 5.6 slugs. If you were to travel to the moon, your mass would still be 81.7 kilograms, but your weight would now be 132.36 newtons or 29.8 pounds, because the acceleration of gravity on the moon is 1.62 meters per second squared instead of 9.8 meters per second squared on Earth. That concludes your tangent for today. Now back to your regularly scheduled forces. Next, we have the normal force. If something is normal, that means that it is perpendicular to a surface. Using that and incredibly advanced logic, you can determine that the normal force is a force perpendicular to a surface an object is sitting on. The normal force only exists when an object is on a surface and is not moving in the plane perpendicular to the surface. So its value is whatever it needs to be to balance the forces in that direction. Next, we have static and kinetic friction. A frictional force is a force that resists an object's motion and is always directed in the opposite direction to the object's motion. Static friction is resistance to start moving an object that is currently at rest, and kinetic friction is resistance to an object that is already moving. Whenever friction is present on a surface, there will be coefficients of static and kinetic friction, notated by the Greek letter mu. Each frictional force can be found by multiplying its respective coefficient by the normal force between the object and the surface. Remember to only apply the frictional force if the problem specifically states that there is a frictional force or that the surface is rough. Next we have tension. Tension is the force of a rope pulling on an object. Tension is always directed away from the object in the direction of the rope. Tension does not have a specific value, but can find the tension by solving a net force equation. So that concludes AP Physics 1 Forces in a Nutshell, Part 1. Since the gravitational force and centripetal force are a bit more involved, I will leave those for Part 2, where I'll talk about the applications of forces I've explained so far. Be sure to check out Part 2 and a video where I go through some practice problems. Links to both will be in the description. So good luck with the rest of your physics, and goodbye.